Hi, welcome to the part 2 of the Shift Left series. Shift Left, think forward, building smarter data from the start. In the first part, we talked about Shift Left, did like an introduction into Shift Left, how we got here, how Shift Left became a thing, and everybody's talking about it. If you've not watched the first part, I do recommend you watch the first part because that is where I did like an introduction into Shift Left and what it's about. In this second part, we're going to be talking about the roles, the data roles, and how Shift Left have kind of redefined the data roles we have in teams. What data roles are today are quite different from what it was when I started my data career. And if you're looking into getting into data, thinking about your best next move, maybe you're a data analyst, you want to become an analytics engineer, you want to go into engineering, or you want to go more into architecting, or you just want to start your career within data. This episode is very necessary, it's very important for you to know how the roles are being redefined into how we orchestrate data and organize teams. And for the part 2, we're going to be talking about how the data teams have moved from being just janitors to becoming architects within the data ecosystem. Now, for years, data teams were stuck in reactive mode. They've been chasing bugs, cleaning up messy reports, and answering what went wrong after it was too late for them to fix anything really. But that's changing. As businesses embrace the shift left thinking, data teams are stepping out of the shadows into the spotlight, not just as support but strategic partners within the data roles. Like I explained, this part of the series is about the transformation, how we've gone from being janitors to becoming architects, and why it's reshaping how companies think about data, structure their teams, and build for trust. A good place to start is to talk about the data supply chain, and I think having an understanding of this is going to help us discuss how teams are being built and the best way to kind of organize things within the shift left thinking. The data supply chain is a conceptual model that treats the flow of data through an organization like a physical supply chain, moving from raw, that is your source data, through the various stages of processing, transformation, and quality control before delivering a final product like a report, dashboard, or even your AI model, and it getting to the end user or going downstream. Because I like using good metaphors to kind of explain my concept, let's think of this like a food supply chain. In the food supply chain, you've got the raw ingredient. Think about the raw ingredient as your source or the activities that bring about the source data. Things like clicks within your apps, transaction within your enterprise application, or user feedback, or just whatever it is. Those kind of activities could be classified as the ingredient that brings about this data you can use to make better decisions. And when you get your raw ingredient, the next thing is to prepare the food. And the preparation of the food can be classified as the cleaning of data, validating data, transforming data, because it has so much activities. That is when you bring all of the ingredients, you cut your vegetables, you mix up your spices, and you try to do everything you want to do for your food. And that is a good way to classify the cleaning of the data. After that, the next thing you would typically do within your food supply chain is the packaging and the delivery. Unless it's somebody ordered for this food online or somebody sitting within the restaurant and wants this food delivered to them, you have to package it in a nice way and have an effective way of delivering it to the person. And this delivery could be like you storing your data, modeling your data, querying your data. It's all about having the data delivered in the right place it can be used, and having the data well managed, well packaged, defining all the different models that needs to be defined within the data, or just storing the data in the nice place within the folder structures and having them within the layers that they are required. And when the data is provided in the right place, then you can now start talking about this data being served to the final consumers. Whoever has ordered for the food now eats the food, and it's where you consume the data. And business users, stakeholders, they consume this data either in reports or AI-driven actions, or they're trying to consume it within a dashboard or within an AI model, and this is where the data is now consumed. Now imagine a situation where you have a restaurant and nobody checks if the ingredients are spoiled until the plate is already on the table. That's how most companies treat data. Nobody goes back to look at the source and what kind of thing is happening within the source. and it's not fixed at the source. Nobody looks at it until the data is already presented on the table for consumption, and that is where we try to figure out that something has gone wrong. Like I explained in the last video, shifting left means putting control checks earlier in the supply chain at the moment when data is created and touched, when the interaction happens. And this is where you try to put a lot of checks earlier to ensure that as you go down the supply chain, you've solved almost 90% of the problem from source before it actually gets prepared. Because if you have the wrong ingredient, you have the spoiled ingredient, there's nothing you can do to the food that is going to make it turn out nice. And that is why it's good to fix it from the source. The modern data team sees the whole chain and design system. It looks at it holistically and not just the dashboard or whatever data model they're working with at the moment. They build test suites, own schemas, enforce definitions, and publish shared metrics. They don't just react, they build the rails the company runs on. So they've gone from being cleanup crews to system thinkers. In the old world, data teams were often placed under IT, and you would have seen those kind of structure back then, or just generally placed under engineering. And that wasn't just symbolic. It kind of reflected how they were seen. They were seen as internet service providers. And their job within the IT was really to react to requests. And they were just there to pull numbers, fix broken dashboards, generate ad hoc reports, and that meant they were constantly cleaning up after the fact. As an example, you could have a marketing team launching a campaign but forgets to tag half the channels, sales updates the CRM with inconsistent region codes, product logs events with different names for sign up complete. The data teams are just left piecing together a puzzle with missing and mismatched pieces. They were data janitors. They were quietly important, but they were rarely invited to the table early enough to make a difference. If at all they were invited, they were just told after the fact. But the moment you start having real-time decisions entering the picture, this structure broke. Even now more with AI, you can't ask your AI to make smart decisions if your team is spending 70% of its time cleaning up after everyone else. You need data that is clean, traceable, and defined from the start, which means data teams need to move upstream in the org, not leave at the bottom. Just like you can see in the diagram. In the first part, you have data teams being brought down. Now you have data teams going up to where decisions are actually being made. So data teams are becoming more cross-functional in their design, and in the approach they use, they are really touching different kinds of cross-functional teams and working across there. Modern data teams aren't sitting in a corner waiting for tickets. They are being embedded into product squad, marketing pods, finance teams, you just name it. And the reason is simple. Being close to the data producers help prevent problems before they even happen. It allows data engineers influence how events are logged. It allows data analysts shape what data gets captured. In summary, it turns passive consumers into active collaborators. And in this world, the org chart has to shift as well. So the data teams embed directly in domains like growth, ops, supply chain. They now advise on strategy, not just output. And instead of them just answering question of what has happened, now they help shape what should we build next? What should the product focus on? We are not just here to answer question on why is the dashboard broken, but we also want to understand what should be built. We want to have a voice in that, we want to recommend, because they kind of understand the data more and they can tell you how best it is to collect the data from source, and the engineers can give input on event logging and all of that. Just think of it this way. Instead of fixing broken dashboards, they are helping design systems that don't break at all. And instead of writing last-minute SQL patches, they are building reusable, tested models that serve many users across board. And finally, instead of being the analyst janitors, they are the architects sitting at the product table and making recommendations. This shift isn't just more efficient, it's more empowering and frankly more fun. Okay, let's talk about data as a product and how the data teams are the architect developing this product. This concept of data as a product was made popular by different data thought leaders. And one of them is Zhamak Dehghani. She had a work on data mesh and kind of flips the old mindset of data just being a tool and thinking about data as a holistic product. So instead of thinking of data as something that flows through centralized pipelines, this concept tries to encourage teams to treat data like a product. And by that, it means that data should have a clearly defined purpose. That is, talking about what questions should it answer. It should have known users who need this and why do they need them. It should also have assigned owners who is responsible for quality and should have established SLAs. How fresh, accurate, and complete should this data be? Under this lens, data teams aren't just coders, they are product designers. They are trying to ask very critical questions like what data sets do we maintain? Are they reliable enough to build models on? Can the downstream users trust them blindly like an API? The truth is that this requires intentional design, it requires working with stakeholders before features are launched, and it requires automation testing, documentation, monitoring to ensure those data products evolve safely over time. Let's talk about the tooling briefly. I'll be speaking more on the tooling in the next episode, but I just wanted to highlight it here to say that this shift wouldn't be possible without the right tools being in place. You have tools like DBT that allows data teams define transformations as modular testable code. You have data catalogs like DataHub or Unity helping teams discover and document assets. And you have different data observability platforms that provide early warnings when things go wrong. Really, there are countless of tools that could be categorized into different buckets. And all of these tools reinforce one key behavior, treating data like a software. That means version control, testing, documentation, monitoring, deployment pipelines, and above all, data having the right ownership. Because when data teams own their work the way software teams do, they stop chasing bugs and start building systems. So the skills that make a great team work. So it's good for you to understand that the skills that make a great data teammate are evolving. Yes, the technical parts still matter a lot. You still need your SQL, you need your Python, you need your data modeling skills. These are foundational and they're not going to change anytime soon. But the new generation of data professionals, they also need product thinking, understanding user needs, trade-offs, and long-term impact. They also need communication skills, being able to explain logic, decisions, and risk in plain language for anybody to understand. And collaboration is also very important, and that is your ability to work cross-functionally with engineers, analysts, project managers, and even the execs. I've spoken a lot about ownership. Ownership is very important because when teams own their data, they're able to think about it like a system and not just something that they build and throw away. Taking responsibility not just for the output, but for the outcome as well. What is that data going to achieve downstream? What kind of value is that data going to bring about? And somebody has to take ownership of that to see it end to end. This is why we are seeing new titles pop up. Analytics engineer, data product engineer, data ops lead. These aren't fluff. They reflect the expanding role of data in business and the fact that data isn't just a support function anymore. It's a core function within every business. To wrap this up, I'm just going to give a summary of all of the key points we've mentioned in this part. First is that data teams are no longer janitors fixing messes. They are architects designing for quality, reuse, and scale. And secondly, shifting left means involving data people early at the design, logging, and decision-making stages. And the third one is the fact that this shift requires cross-functional thinking, new skills, and the right tools being in place. And finally, is about the best data teams today are builders, not just analysts. They create data products, not just charts. Maybe one thing that is important to also remember is the fact that these new data teams, they're helping the rest of the business think about data before something breaks, not after. Which is very critical because that is how data teams are shaping everything now. And that's a wrap for the part 2. In the part 3, we're going to be going more into the tool, which is very important. Please look out for that because we're going to be looking at the tools, trying to explain how these tools are evolving, what tools are necessarily relevant, and how you can also build around that. Please like and subscribe to encourage me to do more of these and to help other people to find this useful material. Whether you're watching on YouTube or you're listening as a podcast, you could just share wherever you listen and let me know in the comment section what you think about this, what you want to hear, what you want to see around this topic, and we'll see how to make it happen, make it possible for you. And I guess I'm going to see you in the next one. Bye for now.